another episode of Gemology for Schmucks. My name is Peter Nelson and I'm here to guide you in everything you need to know about gemstones and jewelry. Today I have 3 mystery stones here, and what I'm going to do is take you with me as I go through the steps of identification. I'm not going to tell you what they are until the end, so if you want to write down this information and make a guess based on the properties that you know about the stones, I highly encourage it. Because the path to understanding about gemstones really is just about accruing enough known variables. What are the properties of these stones? So I've got all my basic equipment right here. I've got a nice notepad full of paper. Well, I mean, it's got a couple of pages, but we don't need that much paper. So the first thing that we're going to do is we're going to pick one of these stones. I have a bluish stone, a lilac stone, and a red stone here. Doesn't matter which one we start with. But the first thing that we're going to do once we've chosen a stone is observe. So rather than pop the box open and have stones go flying everywhere, we're going to put it face down, take our tweezers, rotate it, open the box, and eeny, meeny, miny, mo. Let's do the blue one. Put the others to the side so we don't knock them off with our flailing. And I'm just going to look at the stone. Delightful. But that doesn't really get us very far. So I take my 3-way torch. In yellow light, it looks a little bit purplish. I go to cool light, and it gets a little bit more blue. With a lot of the blue range of colored stones, if you want to call it color change, you can. Some people like to argue that it's color shift. Do I really care? Personally, no. The more intense the change of color, the higher the price is in my mind. So I look for intensity of change. Is there some change in this? Yes. Huge? No. And last, we'll check UV, just for fun. I don't see much. Moving on. So I'm going to write that down. Slight color change, blue to purplish blue. The next thing that I want to do is use my polariscope, because it's free. I like to take the stone in hand for this, crossing the filters. And as I rotate it around 90 degrees, I don't see any blinking. If I'm not sure if this stone is blinking, I can rotate the stone to its brightest position, as opposed to darkest, and then open the filter. If the stone gets brighter, then I know it's singly refractive. Check one more time for good measure. Yeah, nothing changed. We're done with the polariscope. Polariscope, we're going to put SR for singly refractive. So far, we don't have that much information about this stone. So now we're going to pull out the big guns, the refractometer. Taking off the lens here, get the tiniest amount of our RI liquid that we can possibly get. It's not a huge stone. You don't need much. That was a lot. Wiping off the stone to make sure there's no oils on the surface that I'm going to be testing. I locate where the shadow is in the refractometer, and then I put my lens back on. Turning the polarizing lens, seeing if it moves at all. The shadow gets a little bit lighter and darker, but the bottom, that end of the shadow, does not move. So right now what I see is 1.72. Now, in order to be thorough with a refractometer, it's important to rotate the stone, checking for a change in refractive index at each part of the turn. If you want to be very thorough, as you go through 180 degrees, check every 15 minutes. You can be more excessive if you want to. It's all up to how thorough you want to be. I'm obsessive. So check, rotate, check, rotate a little bit more, check. Still looks like 1.72 to me. Okay, there we go. All the way through 180 degrees, and I see no significant change. So it looks like our polariscope did not lie to us. Huzzah! So now I'm going to write down the refractive index, 1.72. Taking a nice soft piece of tissue, I'm going to clean off my refractometer. If the RI liquid crystallizes, it can scratch the glass. We don't want that. This thing is not cheap. And if there are scratches, that can get in the way of the reading, and that's really frustrating. So we've cleaned off our stone. Please do not lick your fingers after this. The stuff is poisonous. So, what do we know so far? Singly refractive, 1.72. Is blue. It changes color a little bit. So now what I'm going to do is try and get a more up-close look with my loupe. Now, yes, I have a microscope right here, but you may not have one of those. So in solidarity, I'm just going to go ahead and use my loupe. I see some thin, colorless needles and various small white crystals. Nothing that I'd say is very distinctive. But it does make me comfortable it is a natural stone. The orientation of those crystals and the type of crystals and needles tends to be exclusive to natural stones. If this was, for example, synthetic anything, a lot of the inclusions could be expected to be curved. And it also seems that there are sets of needles that are intersecting like this. Now, if we can get a good look at what that angle is, that might give us an indicator of what mineral this might be, because the crystal lattice of that mineral is going to be unique. Any inclusions that formed as the crystal is growing are going to form along the lines of that crystal on its basic structure. So we've got colorless needles, colorless crystals, small, scattered. The next thing that we're going to want to use is a chart. Or if you've got a book such as the Handbook of Gem Identification, there are lists of the gemstones and their properties. Oftentimes there's a chart that's entirely organized based off RI, refractive index. Because so far, that's the most distinct thing that we've got. Singly refractive and refractive index of 1.72. So let's get our chart. Now, these massive things I got back when I was studying at AIGS. I'm not sure if they're selling them yet, but if you want some, I would suggest you contact and pester them until they're so annoyed that they decide to sell them. It's a strategy. So 1.72. So I'll just read off everything that's in the close range, and then we can start to eliminate. Kyanite, 1.716 to 1.731. Spinel, synthetic spinel, different type of synthetic spinel, and those are 1.718, 1.719, 1.728. Taphite, 1.719 to 1.723, Grossular garnet, aggregate, 1.72, and epidote. Epidote is 1.729 to 1.768. So right away we can go ahead and cross off all of the stones that are doubly refractive, especially the ones that have a larger birefringence. That's the distance between the maximum and minimum refractive index readings. Kyanite's on the list, but kyanite is doubly refractive, so they're out. Spinel, 1.718, very close. In fact, with my eyes on this machine, could have been 1.718. The difference is not very clear. And we also have to leave room because there are differences inside of nature. The different chemical composition of each stone in each area does leave some range of variance. We don't know what changes the refractive index until they go and test trace element chemistry and a whole bunch of other things. So let's keep looking. Synthetic spinel was an option, but remember we were talking about these inclusions, those needles intersecting in very specific ways and scattered even crystals. Now, if I wasn't sure if they were crystals and I thought they might be bubbles, I would still leave synthetic spinel. Because keep in mind, synthetic, natural, for all of their properties are the same thing. It's just whether or not they were grown in the earth or manufactured in a lab. Given my experience, I will say that I'm confident that this is not a synthetic stone. Scratching off synthetic spinel. Both of them. Taphite. Well, that's also doubly refractive. 1.719 to 1.723. But the birefringence is so small. In fact, with the refractometer, I don't know that you would actually see the line move enough. If you're not super observant, that sort of blink quality that you get when we rotate the polarizing filter could make you think that it is birefringent. But because we also used the polariscope and it didn't blink at all, and we performed the additional test, I'm going to go ahead and say it's not taphite. And then we've got Grossular, but it says aggregate. So Grossular is a very particular type of garnet that grows in aggregate crystals, very small crystals. So in the polariscope, it would show up in a different way. And we also wouldn't be expecting it to be transparent like this stone is. And then finally, epidote. Epidote, we've got 1.729 to 1.768. And the birefringence is pretty large, very large birefringence. So we're going to go ahead and say no. So in this range of refractive indices, around 1.72, singly refractive stones are not that many. In fact, spinel is pretty much the only thing left, especially as we ruled out the aggregate stone. I said it wasn't synthetic because of the inclusions that I noticed when observing with the loupe. So I am confident to say that this is a piece of color change spinel. Next stone. Okay, I'm going to go with this raspberry colored stone. Seems quite different from the blue. So again, I'm going to observe first. It's a raspberry color, quite clean crystal. Take a quick loupe to it. And I am not seeing very much inside at all. In fact, I'm going to pull out the microscope just for fun. Well, in fact, the only thing I see is one small feather over on the side of the stone, and that is not exactly diagnostic information. So what I'm going to do is once we're done with identification, I'm going to go to the lab, get them to give me a second opinion, because they have a different type of lighting basin with their microscope. That may be able to give them some additional information. Well, let's proceed with the identification. Red stone, can I use in the polariscope? No, bad idea. In previous episodes, we've looked at anomalous double refraction, and red stones tend to be suspect that might be the case. Whatever we find in here, we may not be able to trust. So let's not waste time on it. So we move on to the refractometer. Same thing, wiping off the stone, making sure it's nice and clean. The tiniest manageable amount of RI liquid. Too much. We find our line and replace the lens. Seeing something slightly under 1.72. And it ain't moving. Just to be careful though, let's rotate it through that 180 degrees. Didn't move. So we clean off our stone, clean off our refractometer gently, and we write down 1.72, singly refractive. Now, I don't like only having two pieces of information, so I'm going to use the last thing that's available to me at the moment, which is my spectroscope. Red stone, after all. Maybe I see something. But I happen to know that the garnets can overlap in this range to some degree. Maybe 1.72 is a bit low, but this is going to give me a lot more surety, because if it is 1.72, it's going to be the pyrope-almandine garnets. This color would be very rare for that stone, but let's be thorough. So as we've done before, we take our torch, we put our stone on top of the torch, and put the spectroscope directly into the light. I am not seeing what I would expect if I was going to be looking at a garnet in the pyrope-almandine range. That pattern is diagnostic. But let's check with UV just for fun. And in UV, we do get a little bit of fluorescence. So if I had done this before using the spectroscope, I wouldn't have even looked for garnet, because garnets do not fluoresce. Still, this is a pretty muted fluorescence. So maybe there's some trace element of iron in the mixture, or some other element that could be muting the fluorescence, or quenching. Now this one can be kind of difficult because way over in the red area of the spectrum, which is the far side, there are two dark lines. And that tends to be associated with the chromium absorption spectrum. So I've got 1.72, singly refractive, mild fluorescence, and a chromium signature. I think it's fair to say that this is spinel. Now, as to whether or not it's natural or synthetic, I'm going to leave that up to the lab to give me a call, because this is a bit too clean for my setup. Fortunately, it's Bangkok and I have access to reputable labs. Huzzah! So spinel, likely natural, maybe synthetic, we're going to find out. If there were other features that were more distinctive, such as gas bubbles or maybe curved striae, those curved band lines that happen when the crystal is grown in a melt style of synthetic growth, these are the kinds of things you learn about gemology class. Much harder to show on camera. So next stone. And last but not least, we have this cushion-cut lilac-colored stone. Now what is lilac? It's hot lavender. So let's take a look. In warm light, still lilac. Cool light, it goes a little bit more lavender. That's to be expected. These are not full spectrum lights, so we expect some sort of interaction with the stone. Nature's chemistry is complicated. Now we skipped UV last time, so let's do it here at the beginning now. And I'm going to say that's inconclusive. Doesn't look like much. So next we go to our loop, see what we can see. And I'll say that I'm seeing some honestly very similar needles to the blue stone. So let's see what else. Small crystals, and these needles are straight. Some of the crystals are elongated, nothing with a distinctive color, just white or colorless. And none of those needles seem to be intersecting at a specific angle, but still are straight. So that's a good sign for us if it's a natural stone. Let's move on to the next thing. This is pink, so let's try it in the polariscope. Lilac. Okay, I'm seeing no reaction here. It's just generally black. Open the polariscope, and it gets lighter. So that gives a strong reason to believe that it's singly refractive. But let's double check with the refractometer. You know the drill. Plane it off. Small amount of RI liquid. Maybe too small. Bobble your head until you find the shadow. Put the lens back on. I'll let you guess. Well, if you're some sort of prophet, you might have guessed that it's 1.72 or slightly below it. which oddly enough is just like the previous two stones. So we've got singly refractive, needles in white crystals, just like the blue stone, and its refractive index is 1.72. Is it possible? Could it be that this also is a piece of spinel? And according to the process that we have just gone through with our charts, all of these other instruments, the answer is it's definitely possible. In fact, it's very unlikely that it would be anything else but spinel. 1.72 is a very special area. If there is no refractive index difference, and we've checked the polariscope, it can give you a lot of confidence to narrow in that it's most likely spinel. In fact, I'm going to go ahead and say it is, because I bought it. Now, as I clean my refractometer here so we don't, damage our goods, some of you may be screaming from the other side of this lens saying, why isn't he checking specific gravity? And the answer is because nothing else in that range was close enough with the same refractive index, with the same other features that we were looking through that list on, in order to expect something different from specific gravity. And specific gravity is a test that has a lot of margin for error. If there is a bubble on the stone, especially with smaller stones, it can throw off your reading. Also, it takes a long time, and I don't like doing math. So if it's not going to push me forward, why would I do all of the tests? I am confident from knowing that it is 1.72 refractive index and singly refractive. In this range, that's all I really need. Do I need to go and check the spectra? No. What am I trying to distinguish from? So there we are. We've got three stones that look completely different and all end up being spinel. How is that possible? And the answer is because nature is wonderful. And spinel is one of those stones that can be found, albeit in small amounts, in many different places. And the different areas of the globe that spinel grows in have very unique trace element chemistry. So the spinels of Vietnam can be very different from the spinels of Burma, currently known as Myanmar. And the same is true also with Pakistan, Afghanistan, Sri Lanka, and wherever else spinel may come from. So trusting in color alone in a stone like spinel is not something that's going to get you anywhere, because it really does paint the rainbow. Every color, maybe not, but at least be open to the possibility, because who knows when they find a new deposit? What were the chemicals in the earth in that place? Spinel is one of those stones that we call allochromatic, which means that its color comes from another source, as opposed to idiochromatic, meaning that its color comes from its own characteristics, which are always more or less consistent. Something like always more or less. But spessartite garnet is a good example of that. Spessartite garnet is only spessartite garnet if it has that manganese. Magnesium? Let's check. Spessartite. Mn, manganese. Mn, I get those mixed up a lot. So there you go, manganese aluminum silicate. But at the end of the day, with spinel, we can expect that there is a humongous variety of color, and the thing that will help us the most is having that refractive index reading. Some of the inclusion scenes may help guide us further, but they're not really enough to rely on. If we can find out that it's 1.72 and singly refractive, that's going to give us the piece. Now, the nice thing about spinel is that the crystal can occur very clean a lot of the time. So you can get an amazing array of colors. Anything from that ruby red that led a lot of the ancients to believe that spinel in fact was ruby. The largest rubies that have ever been found are actually spinels. The Black Prince's ruby, that's a spinel. And there are many, many other named spinels throughout history that were called rubies. Because gemology didn't exist until about 100 and something years ago. Not that long. And the refractometer certainly wasn't bouncing around. But a lot of the cleaner red stones that you can find in that higher refractive index range, 1.72 is not so far away from 1.76. Your eye isn't necessarily going to distinguish the luster difference. But spinel tends to be quite clean in a way that ruby very rarely is. So while a generation ago, with many of the gem dealers and gemologists that are starting to retire these days, spinel was being given away for free if you were buying ruby. Now things have changed because people have finally started to trust their eyes and recognize, oh, this sells. And so the price of spinel has now come up and is competing with ruby in certain sizes. And I'm not just talking melee. Some of these hot spinels, once you get close to a carat size, you're climbing into thousands of dollars already, just as with ruby. So for some people, these sub 1 carat hot stones are the only spinel that they will ever consider buying. But each color is different. The rarity of that color is based off of the location and the growing environment. And I think it particularly interesting that the hot stones, the ones that we all agree are beautiful, are also naturally rarely occurring in the earth. We don't find many of them. So at that point, it's expected that the price will at some point climb. That natural rarity, that natural collectability is why I went from completely different industry to becoming entirely fascinated with this world of gemstones. Because collectability is one element of value that I believe most people have forgotten. Most people do not understand how to think about collectibles. People know cash. A dollar is a dollar. It's totally fungible. Everyone has to take it. Stocks. I hit sell, it sells now. But collectibles, the truly rare thing, when other collectors recognize the rare, when they have the opportunity and they have the money, they're going to buy it. But while we learn, fortunately, there are smaller stones that are available as color samples for us and great for use in jewelry. Will they ever catch up to that price as the higher end stones? They're less rare. What do we expect? But still, even smaller stones like this are difficult to find in good qualities and good colors. But what is a good color? Sometimes you just want a new thing and you like that color, so you go for something that is moody. You can get a smaller or a larger stone for a much lower budget because it is not anywhere near as rare in these colors. Now, if it suddenly gets really popular, of course the price is going to go up. But if you would like to see more spinel and you're interested in some of the range of colors, I suggest going over to gemshepherd.com and signing up for my newsletter. I'll be releasing a short video soon with a collection of different spinels to show you some of the colors that are available and what kind of prices you could expect for those sizes. Of course, if you're interested, you're definitely welcome to contact us to buy. If you just want to oogle, that's cool too. Please hit like, hit subscribe, leave a comment down below if you've got any questions, or over at gemshepherd.com, you can contact me directly. Otherwise, tell all of your friends about me, and until next time, bye-bye.